Bismillahirrahmanirrahim. Still we are in this topic, which is the indefinite integral. And we say that the integration is the reverse process of the derivative. The differentiation, we are finding the derivative of a function. In the differentiation, given f, and we find the f of x. Small, which is the derivative of the given function. For the integration, this is the differentiation. For the integration, you are given the derivative is equal to f of x, and we need to find f. This is by the integration. So it is the opposite or the reverse process of the differentiation. And we gave different type of example in the first part. Now in the second part, we are going to find some indefinite integral using trigonometric functions. For example, we know that the derivative of sine x equal to cosine, which means the integration of cosine of x dx is equal to sine x plus some constant, because this is indefinite integral. So we know that the derivative of cosine x is equal to minus sine x, which means the integration of sine x dx equal to minus cosine plus some constant c. Using these facts, let's try to find some integrations. Evaluate the indefinite integral. What is the derivative of x divided by sine x dx? Find the integration of secant of x divided by cosine of x. It means that we need to find the function when we differentiate it, we'll get this one, secant of x divided by cosine x, the antiderivative. We know that the secant of x equal to 1 over cosine, and also 1 over cosine equal to secant of x. So if we simplify this one, this is integration. It can be written as 1 over sine x multiplied by secant of x dx. 1 over cosine is equal to secant of x. Secant of x multiplied by secant of x dx, which is equal to integration of x squared dx. And we know that the derivative of the tangent equal to secant square. So the integration of secant square is equal to tangent. We are looking for the function. When we differentiate, we will get secant square. And that will be the derivative of tangent. So the integration of secant square equal to tangent x plus some constant c. Understand? We are in this type of integration indefinite. So we have to add C, the constant. Take another one. Number 2. Integration of 1 plus sine square x multiplied by secant of x dx. So this one can be simplified. Integration of 1 plus sine square of x multiplied by cosecant is equal to 1 over sine x dx, which is equal to integration of 1 plus sine x dx. Now integration of 1 is equal to x. This is the integration of 1 is equal to x. Integration of sine equal to minus cosine plus constant c, because this is indefinite integral. One more, number 3. Integration of tangent square. I don't have direct function. When I differentiate, I will get tan square. So for the tangent square, we can use the identity. We know that the tangent square is equal to secant square x minus 1. Tan square equal to secant square x minus 1. So this function, tangent square, can be written as secant square x minus 1 dx. And we know the integration of secant square is equal to tangent minus integration of 1 is equal to x plus constant c, because this is indefinite integral. So this is tangent x minus x plus the constant c. Let's take one more. Number 4. Integration of sine square x over 2 dx. Since I have this sine to power 2 and I don't have direct function, that when I differentiate I will get sine square. So we have to manipulate this one or just use some identities. We know that the sine square x over 2 can be written as 1 minus sine square x over 2. But in this formula, still I have cosine square, which is, I don't have direct integration for that one. Also, this one can be written as 1/2 of 1 minus cosine x, half angle identity. Sine square x over 2 equal to 1/2 multiplied by 1 minus cosine x, using the half angle identity. This one will be easier to integrate. So the sine square is equal to, using the half angle identity, will be 1/2 1 minus cosine x d x is equal to, I can take 1/2 outside because it's constant, multiplied by integration of 1 is equal to x minus integration of cosine is equal to sine plus some constant c. So this is the integration of sine square x over 2. Again, the indefinite integral, we are looking for the original function of the derivative given in the integration. We are looking for the antiderivative, the original function. And these are different types of indefinite integrations. Sometimes we need to use some identities of the trigonometric to simplify the integration. Some other techniques that will be given later on, maybe the integration by substitution or integration by part. These are two techniques to find somehow some functions that are not easy to find. We have to simplify it by integration by substitution or using integration by part, and this will be explained in details later on.